Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will do some exercises about converting the Reimann sum to a sigma notation. I'll start with the first exercise. If I have 1 plus 5 plus 9 plus 13 plus 17 plus 21 plus 25. When I look to that series, I can find that 5 minus 1 is equal to 4 and 9 minus 4 is equal to 4. If I minus everything in it, 17 minus 13 is equal to 4. So everything is equal to 4. So I know in my sigma notation I have to have a 4. And then I look into my 5 and I realize that the 5 is 4 plus 1. And the 9 is 8 plus 1, 12 plus 1, 16 plus 1, 20 plus 1, and 24 plus 1. And if I look, let me delete this. And if I look at the 4 is a multiple of 4, 8 is a multiple of 4, it is 4 times 2, and this is 4 times 1, and the 12 is 4 times 3, the 16 is 4 times 4, and this is 4 times 5, and 4 times 6. I know I have 1, 2, 3, 4, 5, 6, 7 terms, yeah? So, and the 1 here is 4 times 0 plus 1. So the 5 is 4 times 1 plus 1. 4 times the 9 is 4 times 2 plus 1, and etc. So I know it is 4i plus 1. And my I is equal, because the first one is times 0, I will put it here from 0 to 6 because I have 7 terms. And if I replace 4i equal to 0, 4 times 0 is 0 plus 1, 1. 4 times 1 is 4 plus 1, 5. I have the 5 here. 4 times 2, 8 plus 1, 9. I have the 9 here. So this is how you should think about while creating the sigma notation going from the Reimann sum. You see what is, there will always be something in common in my series, and then I have to find it. I'll give you another example because practice makes perfect. And so we will practice. If I have a series with 1 minus 1 plus 3 minus 9 plus 27 minus 81 plus 243. I know when I have an alternation between negative, positive, negative, positive, negative, positive, I should have minus 1 to the power of something. And minus 1 to the power of something even, it becomes plus 1. And when it is to the power of something odd, like 3, 5, it remains minus. So I see here the 9 is 3 to the power of 2, and the 3 is 3 to the power of 1, and this is 3 to the power of 3, 3 to the power of 4, and I will try on my calculator 243, and I find that it is 3 to the power of 5. So I know there is 3 to the power of something here, but the 1 is 3 to the power of 0. And I have 1, 2, 3, 4, 5, 6 terms, and because I have to the power of 0, I will start from 0 to 5. So I want to start with something negative, and if I put I here, 0 is an even number, so I will start with something positive than negative. So what I do is I put I plus 1. So when it is 0, for I equal to 0, minus 1 is equal minus 1 to the power of 1. So it is odd, it remains negative, and 3 to the power of 0 is 1. So it's minus 1. And then when I is equal to 1, 1 plus 1 is 2, so minus 1 become positive, and 3 to the power of 1, I have my 3 here, and if you try it, you will see that we have it. Let's do another one. if I have another series, which is 1 plus t to the power of 3 plus t to the power of 6. Let me put it down because I want to do some explanation on top. 1 plus t to the power of 3 plus t to the power of 6 plus t to the power of 9 plus t to the power of 12 plus t to the power of 15. So I know in my series I have to have a t and to the power of, we will see. And because I start with 1, so it is t to the power of 0 is equal to 1. So I want my I equal 0 to, I have 6 in my term, to 5. So if I have t to the power of I here, when I is equal to 0, t to the power of 0 is 1. I have the first one, but when I equal to 1, I have t to the power of 3. And if I equal to 1, I will have t to the power of 1, so it's not good. So I will put 3 times I. So 3 times 0 is 0, t to the power of 0 is 1. 3 times 1 is 3, t to the power of 3. I would have it here. And if I equal to 2, I will have t to the power of 6. I have it here. If I equal to 3, I have t to the power of 9. So that becomes very easy. All what you have to do is to find a pattern in your sum or in your Reimann sum to find out the sigma notation. Let's do another exercise. If I have minus sinus x, no, plus sin x minus sine 2x plus sine 3x minus sine 4x, etc. till infinity. Yeah? Plus till infinity. So I know I have an alternation between minus and plus. So I have minus 1 in my sigma notation. And I start with positive. So when I start with positive, that means I want this to be even. So I start with I equal to 0. So then it will be positive sine I x. So, but like I will mess up this. I can't start with 0 because sine ix is sine 0. It become, but I want to have sine x. So what I will do, I will start with 1 here. And here I'll put I plus 1. And let's see. So if I equal to 1, I plus 1 is equal to 2, and minus 1 to the power of 2 is positive, and then I have sine x. When I equal to 2, I plus 1 is 3, and 3 is odd, minus 1 to the power of 3 is negative, and I will have sine 2x. And if you continue, you will see that we have it. So I equal 1 till infinity, because like I put it till infinity here, my series. Let's do our last exercise for this video. If I have 1 over 0 factorial plus x over 1 factorial plus x squared over 2 factorial plus x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial plus x to the power of 5 divided by 5 factorial. So I see like I have 1x, x2, x3, x. I know that there is x divided by something, and I have I. And if I equal to 0, I will have x divided by 0 factorial. So x divided by, I will put in my sum x divided by I factorial. And let's see the denominator. The first one, if I equal to 0, and I have 6 terms, so I started by 0, I'll go to 5. So it becomes 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. It's good. And if I equal to 0, x to the power of 0 is 1. Perfect. 1 over 0 factorial it become. And if x is equal to 1, I will have x to the power of 1 divided by 1 factorial. If I equal to 2, I have x to the power of 2 over y factorial. So if I see that my theory is perfect. So if you like my video, please subscribe to my channel and like the video. This will help me continue doing whatever I'm doing for you. And the only way that I get paid by Google is by the number of like and by the number of subscription, and that will encourage me to do more video like this. Thank you.